Welcome to Numbers Simplified. In this channel, we seek to simplify and solve numerical problems. Today, we'll be looking at the area under the graph, that is integration part 6. And I encourage you to check out the other parts prior to this video. Now, diving into today's business. For y is equal to f of x, we can have a function that is represented in the diagram in this format here. And we are saying that for us to find the area under the graph and the x-axis, so from A to B on the x coordinates, the area is given as the integral from A to B of f of x dx, where in this case our A is the lower limit and the B is the upper limit. So recall, A and B are elements of real numbers, and A is less than B. Great. So now let's take a look at an example. So in the question that we have here, the diagram shows the curve y is equal to square root of 2x cubed plus 10. We are asked to find the area under the graph and the x-axis. We already have the formula. So the first thing that we do is to integrate that function that we're given here, that is y. So in this case, our y is 2x cubed plus 10, all raised to the power half from the laws of indices. And then we integrate this. Recall from our video part 4, we dealt with integrating such kind of functions. So in this case, we would have 2 over 3 times 1 over 6x squared times 2x cubed plus 10, all raised to the power 3 over 2. We still keep our limits. We simplify what we have in the square parentheses. And after doing so, we now substitute for the limits. And recall, we would start with the upper limits and we subtract the lower limits. So if we do so, we are going to have that. And then simplifying what we obtained in the second step, we would then have this bit here, 2 over 3 times 512 divided by 54 minus 12 to the power 3 over 2 divided by 6. And that is equivalent to 1.7 units squared, or square units, actually. That is the proper way of saying it. So now that's how we would leave our answer. But of course, it is advisable to leave our answers as exact. But for the purpose of this example, I decided to use two significant figures. Now, let's take a look at another scenario. If the area happens to be below the x-axis, so recall in the previous section, the area was from the x-axis to the curve. So the curve was above the x-axis, but this time around we are saying the curve is below the x-axis. So now how would we find the area? So in this case, we would say that we will use the same formula. However, the answer would come out negative. Why? Because we are summing up all the y values that are negative, but the answer is the same. Though we are going to get a negative, we would find the absolute value of that answer so that we get our answer as positive, because area is positive. In this example, the question is saying, the diagram shows the curve y is equal to x times x minus 5. And we can clearly see that this graph is below the x-axis. Before we even find it, we know already that this is negative. But anyway, we just use the same steps that we used previously, because in finding the area of the region R, we would integrate. So the integral from 0 to 5 of x squared minus 5x dx would be given by that. So in this case, we are going to integrate the terms individually so that we have 1 over 3 times x cubed minus 5 over 2 x squared, and we are going to substitute the limits. That is from 0 to 5. So recall, starting with the upper limits first, then subtracting with what we have when we substitute for x from the lower limits. So that is what we would have here. Then now, of course, simplifying our work, we would have 125 divided by 3 minus 125 divided by 2. And that would give us a minus 125 over 6. So that came out as negative as expected. But recall, area is never negative, rather positive. So we take the absolute value, which is simplified to 20 and 5 over 6 square units. That is our answer there. Great. So now let's look at another situation. We have another situation now where we have the graph, the very same graph passing through the x-axis. So above the x-axis and below the x-axis. So how would we find this area then, given such a situation? So with such kind of a situation, we are saying that we would separate the areas into two parts, part 1 and part 2. So we focus on the one that is above the x-axis as a separate part, and the one that is below the x-axis as the other part. Why? It's because the one that is below the x-axis will come up negative. So if we have one that is positive and one that is negative, if we just integrate from A to the end B, what we would have is a scenario where the area is underrepresented because the negative is subtracted from the positive, whereas that wouldn't be the case. We would need to consider where the graph crosses the x-axis, in our case, crossing at C. That is the general form. So we separate the positive graphs from the negative graphs so that we get the absolute value of the negative graph and then add with the positive graph. Great. So in this case, our A is the lower limit, the B is the upper limit, and of course, the C is between A and B. And A, B, C are real numbers. So we add the two areas, or maybe in cases where we have more, we add them individually. And recall, we take the positive areas. Let's look at example 3. The diagram shows the curve y is equals to x times x minus 1 times x minus 4. That crosses the x-axis. So in this case, we can clearly see that the graph starts from x is 0, it crosses the x-axis at 1, and crosses again at 4. So we've got 4 points where it crosses the x-axis. We are asked to find the total area of the shaded region. So now we are going to separate our graph into two parts. But now, as we are separating our graphs into two parts, we know that we can actually deal with what we have as our y. We can expand what we have as our y there. As we expand so that it makes our integration easier. Recall, by now, we are not yet making use of the integration by parts. That allows us to integrate these factors separately. So the best way is to just expand all the brackets or parentheses so that we have one huge chunk, a cubic function in this case. So now we integrate these terms separately so that the x cubed becomes 1 over 4x to the power 4 minus 5 over 3x cubed plus 2x squared. And of course, we are integrating from 0 to 1. Then we move on to substitute for these limits. So for the 0 limit, we see that all the terms will go to 0 and we're left with the upper limit. So in that case, when we simplify, we would have 1/4 minus 5 over 3 plus 2, which then simplifies to 7 over 12 square units. That is for area 1. Remember, A1 is the part that is above the x-axis. We still have to look at the second area, A2, which was below the x-axis. And remember, this one right here is expected to come out negative. So there is no need for us to sweat the way we did before. We can just take the third step from area 1 and substitute the limits 1 to 4. So if we do that, we would have that, and of course subtracting the 7 over 12, because remember when we evaluated at 1, we got 7 over 12. That will simplify our work, and our final answer becomes minus 11 and a quarter. But recall, area is always positive, so we would need to get the absolute value of that area, which is 11 and a quarter square units. So now the total area will be given by the area of A1 plus the area of A2. In so doing, we are going to have 7 over 12 plus 11 and a quarter, giving us 11 and 5/6 square units as our final answer. Let's look at another scenario. So we have another scenario in which we have the area enclosed by a curve and the y-axis. Remember, in the previous sections, we were looking at the area enclosed by a curve and the x-axis. So whether it was below or above the x-axis. In this section, we are dealing with the curve and the y-axis. So if we're given x is equal to f of y, we would have that particular graph. So let's use AY for the area so that we do not confuse it with the ones that we were dealing with in the previous sections. So the area from the graph in the y-axis coordinate is integral from a to b of x dy. And that is the same as having integral from a to b of f of y dy. Right, so our a in this case is the lower limit and our b is the upper limit. And recall, a and b are elements of real numbers. A and b are such that a is less than b. Now, let's look at example 4. We have this question. The diagram shows the curve y is equal to 12 divided by the cubic root of 2x plus 1. That crosses point P. So we have that graph over here, and we want to find the area AY, which is in this case the shaded region. And now we can see that we have our A, which is a 6, but we don't have our B, which is the point of intersection with the y-axis. So in our solution, we need to keep that in mind. So we need to find the intersection first. So the best way to do that is to set the x to be 0, because we know that at the intersection with the y-axis, x's value is 0. So if we do that and evaluate that, we would get our y being equal to 12. So our second point, which is the upper limit, is a 12. Our lower point is a. Right, so the second thing that we need to also do is make x the subject of the formula. Recall, this time around, we are actually integrating in terms of y, that is with respect to y. So if that is the case, whatever we have as our function and the terms, they must comprise of y's, not x's, like we did in the previous sections. So now we have y cubed is equal to 12 cubed over 2x plus 1 now. So now we move on to make x the subject of the formula. If we interchange the y cubed with 2x plus 1, we would have that. Then we move the 1 to the other side and divide by 2 so that we get x to be 864 divided by y cubed minus a half. Great. The next thing then is to integrate. So we are integrating from 6 to 12 of x dy, and we know what our x was. We substitute for x, then we integrate with respect to y. So before we integrate, recall from our laws of indices, we can clear the fraction with the variable of interest to us, which is a y in this case, so that we have 864 times y to the power minus 3 minus half. And we integrate that, we would get minus 432 y to the power minus 2 minus half times y. Then we substitute for the 12 and the 6, which are the upper and the lower limit. then we evaluate. So as we evaluate, our answer simplifies to 6 square units. That is our final answer. Now, if you've made it this far, congratulations. I leave you with the following task. The integral from 1 to 2 of 4 divided by y squared minus 1 dy. Remember, your feedback is always welcome here. Like, share, and subscribe. Thank you so much for watching Numbers Simplified. I look forward to sharing more videos, and I encourage you to check out more videos on this channel. God loves you.